Okay, so I just wanted to show just a second video about our gears experiment, because as you can see, the way I set mine up, and hey, this might happen to you because we're working with cardboard and not something rigid, but my gears were slipping. So as I turned, they would kind of slip out of place, and even though they're still turning each other, it's not a true reflection on what these gears should do if they were staying locked in to the teeth that they're supposed to be locked into. So lucky for me, my son has a toy that he uses that is building with gears. And I'm going to use that to show this experiment. And you might want to watch my video here if you find the one that you created is difficult. Now, the other thing you could do if you wanted to stick with your experiment is you could just cheat a little bit and make sure your gears are meshed together, put them down on a table, and kind of turn both just to make sure they're staying meshed together. Let me show you that. Kind of with both hands, just so there's no time where the teeth slip out. And that way you could get kind of a fair idea of what happens as you spin those gears. And as you're working with the larger size, you're going to be able to come to the types of conclusions that we're looking for in this experiment. But for today, I'm going to do just a mini experiment using these guys here. Now, I have two small gears. I have a medium gear, and I have a large gear. I haven't counted to see if I have the same amount of teeth as the cardboard cutout gears. Not really a big deal. I am going to just get a washable marker and color in one of the teeth on each gear so that I know where I started to make it easier to count my full rotations. Okay, well, let me just do a quick count. On this guy here, I'll count the red one first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And here, we'll start with the one I colored in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Hey, what do you know? This might actually work out perfectly. It's a dangerous thing to say. Okay, so I'm going to use the gear with the handle as my driver, and all the other gears that are turning without me touching them are driven gears. And we're going to just play with them one at a time. So in the first experiment, I'm going to spin it 6 times, and I'm going to record that data in my chart. 1, 2, 3, 4, 5, 6. Okay, so your job is to write down how many times that purple gear spun. I spun the orange gear 6 times. How many times did the purple gear spin? And you may need to go back in the video, rewatch that, and count those purple spins. This is a great experiment to have 2 people, one person to count one gear and the other to count the other gear. So if you have an interested sibling at home or parent, see if you can rope them into this learning. Okay, I'm going to set up the middle medium gear. Just make sure that my gears mesh in nicely. Okay, again, I have set it up, ready to turn. My 2 beginning points are starting together, and I'm going to bring my orange one to the top. So my orange one's at the top, and you can see my starting point for my blue one is pretty close to the top. Not perfectly at the top, very close to perfectly at the top of its station. And that'll make it easier for me to count my rotations of the orange one. So here we go. 1, 2, 3, 4, 5, 6. And you may have to go back to figure out how many times that blue one spun around, and then write it in your chart. Okay, let's try the big one. There we go. I'm just going to start with my orange one at the top, and I am going to move my purple one to as close to the top as I can get it to make it easier to count that one too. Okay, so orange one starting at the top, purple one a little tricky to see, so I'll turn this slowly, but you can see it is right here. That's the one that I've colored in. So watch that one as it goes around. Maybe I can make it stand out just a little more. Not with that color. Well, keep your eye on it. It's a carnival game. All right, so here we go spinning. 1. Oh no. I think I had it held a little too straight up and down, and that's why we had a little gear catastrophe. Let's try that again. Just wanted to make it close so you could see it, but I have to keep it so it's not straight up and down. Okay, let's try again. Here we go. You can see the starting point for the purple one is right here. 1, 2, 3, 4, 5, 6. Good. All right. So the assignment is going to ask you how many times the driven gear turned. It's also going to ask you to keep an eye on the direction it's turning. Is it turning the same way as the driven gear, or is it turning in an opposite way as the driven gear? I'm not confident that I was turning clockwise like I was supposed to. So think about, did it turn the same way? Did they both turn like this, or did they turn differently, opposite way? All right. Hopefully that demo allows you to fill that chart in and make some simple, maybe not simple, but make some scientific, that's a better word, make some scientific conclusions about what's going on and why gears could potentially be useful in our life. Okay, I just noticed there's one more section in the chart to fill out, and that's using the medium-sized gear as the driver and the large gear as the driven gear. So I've got my spot to watch at the top on the blue one. It's near the top on the purple one, and I'll start to spin. Okay, this way would be clockwise for your eyes. So here we go. Here's 1. 2. 3. 4. 5. And 6. So make your best estimate. How many times did that purple gear go around? Good luck.